My name's Dave Tilbrook. I'm Senior Technical Fellow and Strategic Research Manager in Hexcel's Innovation Centre in Duxford in the UK. So my role in Hexcel is to ensure our future competitiveness by developing new capabilities and future enablers for products which will enable us to tackle aspects such as green transition, sustainability, smart structures. So our original introduction to IMDEA was actually through our relationship with Airbus whilst we were working on the A350 XWB material developments. And we encountered IMDEA as being a very competent research partner of Airbus. After that program finished, we started exploring a more independent research relationship with IMDEA, and we've used it very much as a way of exploring either new experimental methods or to answer difficult to answer questions. And IMDEA have proven themselves to be very practically focused, but also extremely competent in terms of their computational ability and mathematical modeling capabilities, and that's a powerful combination for solving material-based problems. IMDEA, as a research institute, combines an excellent ability to execute focused industrial scale research and targeted research to the needs of industry. That's coupled with the ability to model material systems extremely well. We find that this is very good complementary capabilities to an industrial research team where we're focused on material development, scale-up and characterization. The challenge that everybody is always working on is the ability to produce increasingly advanced composite structures at scale and cost. And that's definitely the first challenge which needs to be overcome to enable new generations of say, smaller aircraft to use composite wings. Otherwise, aside from that, we have the challenge of sustainability. So composites have a very strong card to play in terms of reducing fuel burn and impact on green aviation. But we need to make sure that we've got solutions for materials that go into them and for the use or reuse and recycling of the materials at the end of their life. An issue which has been well known and worked around for years around composite use is the formation of microcracks. Iker Lizarralde's industrial thesis that recently completed, this was a fantastic example of how IMDEA can actually enable proper answers to be developed. Iker did some fantastic work with IMDEA on using microtomography capabilities in the institute here, combined with methods which he developed to enable the analysis of microcrack formation in a variety of different composite structures. And this has confirmed some mechanisms and actually enabled us to understand how our composite structure relates to its durability. And this is going to be particularly important as we go down the road towards developing materials which are going to experience far wider extremes of temperature as we're likely to encounter if we're doing, say, cryogenic storage tanks for low carbon propulsion. Ultimately, it's a case of remembering it's not just about speed, it's about speed and cost. So reducing the capital assets that are required to produce parts at high part counts is absolutely essential for the future. We've had a number of projects, and there's a high degree of trust there and actually personal relationships between different members of the technical team. We had some IMDEA PhD candidates actually working in our laboratories. That's something where now what I'd like to do is to take that to the point where we work collaboratively on some critical challenges which perhaps may go over a longer period of time, and to establish the best way of doing that. We certainly want to have collaborative projects with IMDEA in future, hopefully around activities like the digital twin and sort of development of more fundamental models to predict material performance.